All right, guys. So sort of like that last one, which is nice. What's the population? Clients of that insurance company, I like it. Or those companies. Is everybody cool with that? All clients. You can even be more specific. All clients. That's awesome. A sample. So several different ways you could say this. All right, I like it. A subgroup of those clients. 78 randomly selected clients. However you know. Yes.
Would it be wrong to just say, well, whoever is being surveyed is the sample?
No, it's not wrong. I mean, it's more of a definition, really. You would say a subgroup that I survey. You know what I mean? I mean, it is going to end up being whoever you survey.
So should I say whoever is being surveyed with the insurance?
Not necessarily. So in general, your sample should use the same language that your population did, but you're going to make it more specific. So if my population here is all clients of the insurance companies, then my sample would be a subgroup of the clients of the insurance companies, or 92 randomly selected clients of the insurance companies, or something like that. I like it. What about the parameter? Out of each client.
All the clients.
Yeah, the mean healthcare costs of all the clients, the insurance companies. I like it. Right. I see what you're saying, but it's, you got to really make sure it's referencing the population. And then the statistic would be, oh, sorry.
Can we just refer to that as like a projection? Are we supposed to be calculating for that?
Oh, the error?
Yeah.
So the error is going to come in later.
Okay.
That's what we're trying to make. Well, I think that's what you mean. That's what we're trying to make an inference about everybody. Here, we're sort of defining what the parameter would mean. We're not giving a number for it yet, because we have to give a range of numbers, like you said, because it's only a sample we got. But we don't have any data yet. I like it. So the statistic would be, yeah, the mean health cost of the clients in the sample. I love it. I mean, do you see how this is nowhere near as weird as it first sounds? It's just directly applying those definitions. Variable.
Average health cost per year.
How much of the health cost?
Yeah, don't bring the word average in. Average or percentage is what you do with the data. And these questions are, how do you get the data? What's the question you're going to ask each person? So if you had a person, this is how you imagine. You had a person from the sample sitting in front of you. You say, hey, congratulations. You've made it to the sample. And then you ask them, how much do you pay for healthcare every year? So it's how much each client pays for healthcare every year. Right? And then what about, yes? What's up?
I was wondering, how do you figure out, the time frame? You said, every year.
Oh, just because they reference each year.
Yeah.
Yeah. Cool. So what's the data? Give me some data. $5,000, $200. It's going to be some. We're assuming it's this country, but I would love it if somebody told me, 8,000 euros, whatever. Yes.
Is it the cost of each client's health insurance, or is it the mean average or slash average?
For the variable?
No. I thought you were on average. You're on mean.
I'm sorry. Well, the data is just going to be each answer that they would give me. So I always imagine the data. The variable is the question at the top of your blank paper that you're going to ask everybody, and the data is everybody's answer. So that's why the data, they just want you to give some examples of what it could be, because it's just a list of answers to the question. I like it. I like it. I like it. Yes?
What's the
Statistic? So that is a description, a numerical description of the sample, the same way the parameter is a numerical description of the population. So for this question, it would be the mean health cost for the clients in the sample. Yeah, so you could say if your answer to the sample was 80 randomly selected insurance company clients, then your statistic answer could be the average health cost for those 80 selected clients.
So,
You see that you always want to reference your sample.
so the answer is the cost of one samples. So the answer will be the cost of one samples.
No, it would be the cost, the average cost of everyone in the sample. And yeah, more general. Is everybody with me? A little bit.
Variable or the data is what you're answering right now.
Statistic.
Statistically.
Yeah. So the word average or percentage, that could only show up in the parameter or the statistic. 'Cause the parameter statistic, that's where you actually do something with the data. You find the average of the data, you find the percentage of people that don't pay anything, whatever, right? Like it or like it. Variable and statistic is more individual, not an overall something. Okay, maybe. All terminology is so awesome. Okay, all right. So to continue this terminology fest, just so you know, we're basically through section 1-2. Oh yeah. It'd be like an etch a sketch. I could just shake it. It's gone. Oh. Yeah, let me make sure I didn't miss anybody. Oh, okay. We can know about that. I like it. So a couple things we got to talk about. Let me first talk about the different ways you can sample things. And somebody already brought up a few different ways earlier. So sampling methods. And then we'll talk about... Oh, that's so funny, Jeff. That was even funnier. Sorry. And then we'll talk about some specifics about types of data. And then I think we'll call it a day. We'll see what happens. Would you... Yeah, we'll go on our field trip today, I think, and get it out of the way towards the end of the class. Cool? That way I can end up at my office. So, the goal is always a random sample. And we basically already defined what that is. So random sampling is the goal. There are multiple ways to get there. So what was the basic idea? Well, how do you know it's going to be a truly good representative sample? A true random sample, as long as, yes, everyone or thing in the population has a chance to be chosen for the sample. Like, so that's what a random sample is. Every element in the population has a chance to be in the sample. Oh man. All right, here's a little worse than normal. Now, let's get more specific. So that's kind of like the goal of every sampling method. There's something called stratified. Oh, actually, I'm sorry. Let me start with systematic. That's something somebody said earlier. Systematic. So there's got to be some kind of a system to it. So that would be, we did one like that earlier, didn't we? That was where I was like, yeah, and then the fourth person after that. So if I go outside and take the temperature every 20 minutes, that's systematic, right? If I take every third radio off the assembly line, that's systematic. You with me? There's some system to how I'm doing things. Why is that still a type of that is a type of random sampling? Because the one thing I left out of the definition so far is, where do I start? I randomly choose where I start. Because if I always start with the first person, well then the second person ain't got a hell's chance to get in there. It's no good. Maybe. So systematic, every nth item, first item, chosen, random. My God. Don't go by what I write. Go by what I say. I think that's Cyrillic. I don't even realize I knew that language. Might be Egyptian. Chicken scratch. So the next two kind of go together. Stratified and cluster. Both of these have the same first step. Break the population into groups. So somebody earlier said something about making sure you have a certain number of women, a certain number of men, right? Let's say you're at a high school and you want to know how the students feel about something, and you don't want any group of students to get all upset about. So you take a certain number of freshmen, a certain number of sophomores, a certain number. You with me? So what's the first thing I did with my population? I broke them into groups. I could have broken it up into other demographic categories, ages, races, whatever. You with me? Okay. So some kind of group that's broken up to. I can break it up into zip codes, and then take a certain number of people from every zip code. Right? So that's what I'm talking about right now is more stratified. Stratified is when you break it up into groups, and then you take some from each. Some from each. That's the second step. So if there were 4 classrooms, and I took 8 students from each classroom, that is stratified. I've broken up into 4 classrooms, and then I've taken some from each. Is everybody with me? So that's like the freshman, junior, sophomore, senior thing, right? Cluster is where you break them up into groups, but then you take entire groups randomly. So I randomly choose that one and that one. And I take everybody and I leave everybody from the other ones out. Is everybody with me so far? So this would be stratified. Stratified is some from all. Unfortunately, cluster just all. Cluster is not that. Cluster is all from some. The other way around. All from some. So if I took, randomly picked 7 hospitals from California, and I took all of their patient records, that's cluster. Because I left out all the other hospitals. And some people will feel like, well, then those people didn't have a chance. Well, yeah, they did. Because I randomly selected the hospitals. It could have been that hospital. Do you guys see the difference? Don't look at it after it's happened. Look at it before it's happened. Is there anybody I'm excluding that's a patient in a hospital in California? No. Because I'm randomly selecting the hospitals. It could have been any of them. Just here, I just take everybody from those hospitals I picked. Stratified would be, I go to every hospital and I take like 30 patients from each hospital to be in my sample. I like it. Cool, I like it. Real quick word about cluster. I was teaching this, actually it was an intercession course back when it was 3 weeks. Shit. And there was a student of mine who had been a veteran in the Iraq War, and he said, cluster sucks, cluster's crap. Don't even talk to me about cluster. So I was like, holy shit, I never had somebody with such a strong opinion about cluster sampling. So I talked to him after, and he told me something about, there was a report done on the state of things in Iraq, and the report later was completely rebuffed because they did cluster sampling of areas in Iraq. They broke Iraq up into these little areas, but they didn't choose randomly. They chose the safe places because they're like, I don't want to go somewhere where it's not safe. This is actually a true thing, by the way. So they chose the areas they knew would be relatively safer, to ask people there how things were going, or to look to see how things were going. Obviously, there's probably going to be some bias because the places that are not as safe probably won't be doing as well, right? You understand? So I explained it to him, and he kind of was like, oh, shit. So it was a misapplication of this method, not the method itself being shit. Right? Does that make sense? So I love that example, and we had a little discussion in class. It was great. All right. Cool. So how are we doing so far? So there's one last one. Yes? Automatic system. Oh, every nth item. First item chosen randomly. I like it. I like it. She already knew what it was. She just wanted to test to see if I really could read it. I appreciate that. Where'd the other pen go? There. One last sampling method is crap. I'm going to put it over here. This really is crap. It's called convenience sampling. So if I used you guys to say something about all Grossmont students, do you see why the word is fantastic? You are remarkably convenient for a couple reasons. You're here already. I don't have to do any work. And you have to do it because I'll fail you otherwise. Yeah, answer the damn question. Right? So that's remarkably convenient. Right? So convenient sampling is standing outside of a... Like if I stood in the parking lot and asked people as they walk by what they thought about Grossmont College, why would that not be representative? For tons of reasons, right? You guys understand?
Yeah.
So there's when it's convenient, very often there's going to be things that make it possibly biased in some way. Like, for example, the worst thing is everybody walking through the parking lot a student at Grossmont?
No.
Okay. Right, so that's a possibility that something could be wrong. All right, maybe. So convenience, I'm not even going to write anything. It's all in the word. Is that cool? It is a convenient way to get it, and you basically you could happen to pick the best sample ever, but I have to throw it out because you didn't put any effort in to make sure that it was representative. These put some effort in to make sure they're representative. Real quick, this, and this, if done correctly, are all types of random samples. Are you guys with me? Like here, is there anybody that didn't have a chance? No, everybody had. Here, same thing. They all had a chance, right? So they are specific types of random. So if you say random sampling when really it was stratified, I have to take points off. You have to be as specific as possible. Now, if I say I put all the names in a hat and chose 3 names out, what type of sampling is that? It's not convenient because I put everybody in. Everybody had a chance to be in there. I had to actually write their names on scraps of paper. But you know what I'm saying? So I made sure that everybody had a chance to be in there. It's none of these, though. It is just pure random. So there will be situations that are just pure random, but if it's more specific, you have to be more specific.
How do you feel about if it was stratified and then someone wrote like random comma stratified?
I'm with you.
It's random, but they're like now defining
I love it.
what it is. Okay.
Sure.
So does it make sense to say that what separates stratified from random is that stratified is more of like an organized random sample?
Beautiful. More organized. I love it. Each of these are more organized. This is definitely, organization is his definition. But these are obviously more organized, right? This is just put everybody in a hat, pick them out. Yay! So if I do that with my high school example, is it possible to only get seniors? No. Totally. Yes, it is. If I put every student's name in a hat, I pick out 500 people. If there's, my high school had 600 something in its graduating class. So, it's possible to get nothing but seniors. So will my results be skewed? Most definitely will be, right? Whatever the question is, right? Even if not, I got to throw the damn thing out. Would I know it necessarily if I did that? Not necessarily. So that's why there's certain situations where you definitely want, like stratified, you would definitely want to do that there so that everybody has a voice. But it's still a type of random sample, so you're not biasing your data, or you're doing everything you can to not let it be biased. All right, maybe. All right. So I just want to do a little bit more, and then we're done for today, and then we'll take our little field trip. Yeah. Oh, beautiful. Don't get too used to leaving early. How long am I supposed to be here?
12.
Oh, so 12? 1220. That's. Let me see. All right, let me make a note. Who not to ask things. All right. Has everybody got what they want there? More than you wanted? Okay. All right. So last little piece. So that was talking about different ways to collect your sample. Now we're going to talk about what types of data could you collect from? What types of variables could you talk about in association with that sample? So you have qualitative data and quantitative data. Quantitative is a little bit easier to start with. The root word of quantitative seems to be related to what word? Quantity. So quantitative data is what I call truly numerical data. You can do like subtraction and stuff. I mean, it's truly numerical. Very often it's some kind of a measurement, but not always. Right, so if I said the height of men, that would be quantitative because that's a measurement that's actually truly numerical. If I said social security number, it's got the word number in it, but is it truly numerical? If I subtract your social security number from your social security number, do I get something? No. I mean, do I get something that means something? Let me be careful. It was really weird. One semester I had a bunch of people from the women's basketball team. So I said, if I subtract your jersey number from your jersey number, do I get anything? And they looked at each other like, you get Michelle. She's number 17, she's number 9, she's number 8. Holy shit. I'm like, oh God. But you know what I mean. So does that make sense?
Yeah.
So like jersey numbers would be qualitative. Social security numbers would be qualitative. Zip codes. I'm better than you because my zip code's higher. You know? Shit, right? You guys kind of with me? So that's what I mean by truly numerical. Yes?
So it's no math, but qualitative.
Yeah, qualitative is a quality, it's a characteristic. So hair color, stuff like that. So characteristic data. Something's called categorical. So type of car you drive, right? I can't do Hyundai minus BMW. What does that imply? Yes.
Something truly can't.
Yeah, but be careful. There are other things here. They don't all have to be measurements.
And then qualitative. Louder.
For qualitative, you can't measure it. Yeah, I can't take an average hair color, for example. I can't do something numerical with
You
hair
take the
color.
average number of hair color, but that's still
Sure.
quantitative because you just counted.
I love it. So qualitative, I could do like percentage of people with brown hair, right? But then I can do percentage of almost anything, really. Whereas quantitative are truly numbers. I can do more with them.
Can you give an example of quantitative?
Quantitative would be, for example, how the temperature today. For example, right? The temperature, your age, the year you were born. Yes?
For qualitative, you can have things that are between. So you can have brown or net and blonde, but you can have 12.5 and 13, which is in between 12 and 13 for quantitative.
Well, quantitative, that's getting to like discrete and continuous. That's coming up. So quantitative could be continuous or discrete. Doesn't really matter.
Qualitative can't.
Qualitative, definitely not. Yeah.
That helps me know which.
Okay, I got you. That's cool. Yes, sir.
Would weather be qualitative? Like is it sunny or cloudy?
Yeah. So that's categories, right? That's a characteristic of the day, right? Now, so if I say it's a sunny day, that's qualitative. If I say there's 10% cloud cover, that's quantitative. Now, I've measured the cloud cover. I could do something with, and tomorrow it's going to be 20% cloud cover, so there's going to be 10% more cloud cover tomorrow. I can do numerical things with them. See? Description, I love it. So, but it's not a numerical description. right? It's just a pure name description. It's just a name of something, right? It's a category, characteristic. Is everybody with me there? So quantitative is truly numerical data. Qualitative is not truly numerical. We talked about a few numbers that are actually not numerical. So it's a number, not truly numerical. It's just a name for you, right? Okay. Okay. Let's get a little freaky. Yes?
So if you add a number to qualitative data, does it make it quantitative? Like if you're talking about sunny days?
Yeah, if I said last week there were 5 sunny days, then the data is actually the number of sunny days. I like it. So that would be quantitative. Bless you. All right. And then somebody already brought up continuous and discrete. It's a little easier to start with continuous. So continuous means something like I don't skip anything. It's continuous. So if I asked you how many doors are on your car, can you give me a continuum of numbers, or can you only give me certain numbers? Right? If somebody tells me they have 2.93462 doors on their car, I'm like, are you the kid with the 2.5 kids? And I don't want to get in your car. I don't want to go to your house. I don't want anything to do with you. Goodbye. Right? What the hell? It's either a door or it ain't. It don't work. Well, then it's a door that don't work. You with me? So that would be discrete. Discrete are the ones that can only have certain finite values. They skip a bunch of shit. So if I ask you now, then be careful. The mistake people make is, if I said your backpack weighs 8 pounds, they look at the number 8, they say that's a whole number, so it's discrete. Well, that's shit. If I say the weight of your backpack, is that continuous or discrete? Continuous, because you can weigh it more and more and more precisely. Now, if I ask you how far away do you live, will you ever say you live 19.134629334? What's that? Oh. Huh?
Different from wherever you're at.
Yeah, okay, I got you. I'm with you. But you would never say that precise for whatever it is, right?
No.
You would say about 20 miles, you would say about 3 miles, you would say I live underneath here. They haven't found me yet. I live on campus. I usually emergency showers in the biology department. This is memories of grad school came in there. Somebody was actually using the emergency shower. But hey, you do what you got to do. So continuous is, it could take on a continuum of values. Not what value is it, but it could take on. So really, any measurement, almost any measurement here, right? So your height, you can get it more and more precise. But the number of TVs in your house, can you get it more and more precise? No. It's 2. It's about 2. It's like 1.7 TVs, because this one only works 70%. No, it's a TV. It's not a... Does that make sense? I'm not going to write anything. Is that cool? Continuous is data that could take on any value. So the way I do this, if I have a question about this, I say, would it make sense to say 7.394 whatevers? And if it doesn't, it's discrete. If it does, it's continuous. Now be careful. What if I said, this gets a little weird, gas prices as listed at gas stations? Is that continuous or discrete? Have you ever seen 2.6877493 cents dollars? Have you seen that? No. But you see my point. I was like, where have you been? Sorry. Very accurate gas station. You guys with me? Yeah. So it doesn't have to be whole numbers. I want to make sure that the distinction is there. It just has to jump over. It can only have a finite number of values. So what could you see at the gas station? 1.999 back in the day. Or on the East Coast, actually, like it was over the break. 2.67, that last number is always 9, have you noticed? Of course it is. You see the 267 and they put that little tiny 9. You never see more than that. Well, at least I've never seen more than that. right? So that's why the gas prices as listed at gas stations is discrete data, because it jumps. What would be the next thing after this? 2.00, probably 9, but you know. It jumped a whole bunch. And it didn't use this, it didn't use this, it didn't use any of that. It just jumped to the next one that went out to this place. Does that make sense? I mean, discrete jumps. There's only a finite number of values you could use. Continuous, there's an infinite number of values it could use. And still makes sense. Okay. Okay. So last thing for today. Right? It's going to be your favorite phrase. Last thing for today. Is this guy still going?
So if you could write something for me, and say that continuous
Yeah.
data, the number
Yes. So, for example, the weight of your backpack could be anything from the weight of the things in your backpack could be anywhere from 0 to whatever it makes, to the breaking, what the weight is going to break your backpack. You with me? Up to like 40 pounds or whatever. Crazy people that go hiking have a lot of shit in their backpack. You guys with me? It can take on any value. Oh shit! What notation is this? Interval notation. So it can take on an interval of values. It can take on a continuum of values. It can take every number in there. Now, if I said there's 140 parking spots, and I want to know the number of cars currently parked, I wouldn't write the